9.1 is on inverse and joint variation. But before we're going to talk about those, I'd like to talk about direct variation to refresh your memory on that from last quarter. So again, direct variation is as one variable increases, so does the other, and vice versa. As one variable decreases, so does the other. It is the equation y equals kx, where k is your constant of variation. And here would be some examples of direct variation. If I have a recipe and I'm going to double it, I would double the butter, double the sugar, double the vanilla, double the eggs, etc. So this would be y equals 2x. In a table, as x increases by 1, y increases by 2. So this is also y equals 2x. And notice the y-intercept is 0. Here is a graph. This one is y equals 3x because I go up 3 over 1. And notice the y-intercept is still 0, 0. So when you read these, the variables x and y vary directly. The minute you see the word vary, you're going to write equals k. And if it's directly, it's going to be y equals k times x, because direct means to multiply by x. Then we can substitute our values in. It says when y is 15, x is 3. So I'm going to put 15 here equals k times 3. Divide by 3, k equals 5. We are always going to take our k and substitute it into our original model. So this becomes y equals 5 times x. And there is my equation. And then part B, find y when x is 9. So I'm going to plug 9 in here. Y equals 5 times 9, which is 45. It says using the following data, decide whether there is direct variation, and if there is, write the equation. So in this case, we know exactly what our x's and y's stand for. X is the number of hours we work, and y are the wages we earned. So when we worked 3 hours, we earned $12. When we worked 6 hours, we earned $24. When we worked 9 hours, we earned $38. And when we worked 12 hours, we earned $50. So direct variation means y equals k times x. So if I put my y in here and my x in here, if I solve for k, I get k equals 4. For this to be direct variation, k must also be 4 on every other point. So I'm going to test it on all the points. So if I test k equals 4, I would have y equals kx. I would have 24 equals, my k was 4, times 6. 24 equals 24. That checks out. 38 equals 4 times 9. 38 equals 36. No, it does not. So this is not direct. Our next example says X is the ounces of nuts and Y is the price. So 8 ounces of nuts cost $2.40, 16 ounces of nuts cost $4.80, and 40 ounces of nuts cost $12. Again, we want to see if it's direct. So Y equals K times X. Y is 240 equals 8 times K. Divide by 8, I get 30 cents equals K. So Y equals 0.30 X. Let's check this point, because if it's direct, that K should follow. $4.80 equals 0.30 times 16. 4.80 equals 4.80. That checks out. And I have one more point. 12 equals 0.30 times 40. 12 equals 12. That checks out. So my equation of variation is Y equals 0.30x. 1 ounce of nuts costs 30 cents. The next variation I'd like to talk about is indirect variation. This also can be referred to as inverse variation. Inverse and indirect are synonymous. So if direct means as one amount increases, so does the other. Indirect, the opposite, as one amount increases, the other will decrease. In our equation of variation, direct was Y equals K times X, so indirect is going to be Y equals K divided by X. The inverse operation. In a table, this is what indirect variation looks like. Here it looks like we're increasing by 2, and then my y's are constantly, x's are increasing, my y's are decreasing. Decreasing by 3, decreasing by 1, decreasing by 0.8, decreasing by 6. So as x's increase, y's are decreasing. Graphically, as my x's increase, these y's are decreasing. As these x's increase, these y's are falling. So this is an indirect variation. Let's try a problem. X and Y vary inversely. Again, anytime we see this word vary, we write equals K. Since it says X and Y vary inversely, it'll be Y equals K inversely means divided. K divided by X. So Y is 6 and X is 1.5. So 6 equals K divided by 1.5. So to solve for K, I'm going to have to multiply both sides by 1.5. And I get 9 equals K. Again, remember to substitute that K back into your original model. So I get Y equals 9 divided by X. There I wrote my equation. It says state the constant of variation. Well, my constant of variation is 9. K equals 9. Use the equation to solve Y equals 4 when X equals 4/3. So Y equals 9 divided by 4/3. That is 9 divided by 4/3, which means 9 times the reciprocal 3/4, which is 27/4. This question says, do x and y vary directly, inversely, or neither of the two? So in order to see this, we want our equation to read y equals, and we're going to see if it is k times x would be direct, or if it is k divided by x would be inverse. If it is k any other operation, plus or minus, absolute value, square root, it would not be anything, so it would be a neither. So we want to solve for y equals. So I divide by x, I get y equals 4.8 divided by x. That is indirect or inverse. I want to solve this so it reads y equals. So I'm going to have to multiply both sides by 1.5. I get y equals 1.5x. So that is direct because I am multiplying. I'm going to subtract my x. Negative y equals 10 minus x. Divide by each of these by a negative 1. Y equals negative 10 plus x. So this is neither because I am subtracting 10. Indirect means dividing by x. Direct means to multiply by x. Same directions. Direct, inverse, or neither. So again, we want, these are my x's and these are my y's. I want to see my x's are increasing, my y's are decreasing. So I'm thinking it could possibly be inverse. So if I'm testing that, it would be y equals k divided by x. So if I take the first one, 30 equals k divided by 10. Multiply both sides by 10. I get 300 for my k. So it would be y equals 300 divided by x. Now I'm going to test this point. 15 equals 300 divided by 20, which is 15. That checks out. Now I'm going to test this point. 10 equals 300 divided by 10. Or excuse me, divided by 30. That equals 10. That checks out. 7.5 equals 300 divided by 40. 7.5, that checks out. And lastly, 6 equals 300 divided by 50. That is 6. So my equation of variation is inverse, y equals 300 divided by x. Okay, let's try this one. Again, it looks as though my x's are increasing, and this time my y's are also increasing. So I would assume direct. So let's check if I have a constant to make it direct. So I'd be testing y equals k times x. So my first one, 15 equals k times 10. Divide by 10, k equals 1.5. So y equals 1.5 times x. That's what I'm testing. So when I try this point, 30 equals 1.5 times 20. That is 30. That checks out. 45 equals 1.5 times 30. It's 45. That checks out. 60 equals 1.5 times 40. That is 60. And 75, does it equal 1.5 times 50? And yes, it does. So it is direct variation. Y equals 1.5 times x. Now all joint variation means is a quantity varies directly as the product of two quantities. The product. So it means we still have variation. So z equals k times x times y. So you're going to join by multiplication. So we have to read our sentences very carefully. We see z varies. I see this word varies, so I automatically write down equals k. Then I see jointly, so I'm going to multiply. So I'm going to put my times down with x and y squared. In front of varies is z, and I have my equation. Okay, let's try the next one. Y varies. So I write down equals k. Directly means multiply with x. And inversely means I'm going to divide by z squared. In front of the word varies is y, so that goes in front of my equals. Next, I have y varies. Whenever I see varies, I write equals k. Jointly means multiply with x squared, square root x, and inversely means divide by z. In front of the word varies is y. The ideal gas law states that the volume V in liters varies directly. So right now I've got equals K times V. Okay? With the number of molecules N and temperature T and varies inversely, which means to divide by pressure P. It says the constant of variation is R. So I'm going to replace this K with a capital R. Write your equation. So there's my model to substitute in. Estimate the universal gas constant if V is 251.6 equals R times N, which is 1, times T, which is 288, divided by 9.5. So to solve this, I'm going to multiply by my denominator and divide by my numerator. So I'm going to multiply both sides by 9.5 and divide by 288. and I get my constant of variation to be 9.5 divided by 288 times 251.6, 8.3.